Hey guys, how's it going? Welcome to the fifth in a series of 7 videos where we look at the derivations that you need to know for the Advanced Higher Physics exam. In this video, we look at how to derive an expression for the kinetic energy of an object undergoing simple harmonic motion, and this is from the quanta topic. So let's get started. Now this derivation is quite short, but it's still one that you could be asked to do in the exam. So we're going to look at how to derive an expression for the kinetic energy of an object undergoing simple harmonic motion. And it's this equation here that we want to get to, Ek equals a half m omega squared times a squared minus y squared. So we want to start with the familiar kinetic energy formula, Ek equals a half mv squared, and remember that's on your relationship sheet. And then you want to substitute in the expression for v, i.e. the velocity of an object undergoing SHM, which is this one here, v equals plus or minus omega times the square root of a squared minus y squared. And check out the previous video in this series if you want to see how to derive that. So if you substitute this v expression into this equation here, then we end up with Ek equals a half m times, in brackets, plus or minus omega times the square root of a squared minus y squared, and that's all squared. And then what you want to do is just multiply all of this out. So we end up with a half m times omega squared times a squared minus y squared, because the squared term will cancel out the square root term here. So that gives us our final equation, kinetic energy Ek is equal to a half m omega squared times a squared minus y squared in brackets. And remember, because of the brackets here, you could actually expand this term to give you Ek equals a half m omega squared times a squared minus a half m omega squared times y squared. So just to quickly recap that, you want to start with your familiar kinetic energy equation, which you probably saw as early as National 5 Physics, which is Ek equals a half mv squared, and then you want to substitute in the expression from the relationship sheet for the velocity of an object undergoing SHM, which is v equals plus or minus omega times the square root of a squared minus y squared. And if you substitute this into here, you get Ek equals a half m times plus or minus omega times the square root of a squared minus y squared all squared. But then if you square this term in brackets, you end up with the equation we want, which is Ek equals a half m omega squared times a squared minus y squared. So remember, that's your kinetic energy. M is the mass of the object undergoing SHM, omega is the angular frequency, a is the amplitude of the object, and y is the displacement of the object. That's all for this video, folks. I hope you found it useful. If you did, give it a like, subscribe to the channel, and I'll see you in the next one. Take care.